All right. Thank you very much. I'm Doug. This is Ward, and today we're going to talk about how at Peloton we spent about the last year reducing our build times by 50%. To give some context to the problem, we're going to take you back to the beginning when we first started. Life was pretty simple at Peloton. We had a single piece of hardware. We had the support with a tablet that ran one Android app. Pretty straightforward. Fast forward to today, that ecosystem has grown significantly. We have numerous first-party hardware that all run different Android apps. We've also supported a number of third-party services that support their own Android apps as well. So taking a look at our single Android mono repository, we've seen a massive amount of growth over the past few years. We have over 100 Android devs merging over 1,000 PRs every month across 15 different Gradle projects that have over 900 modules. For developers, what this means is every time you put up a PR, there's a significant amount of build jobs that need to kick off. Some of these jobs for developers are pretty simple. They're singular jobs, things like tools that we use to determine whether our APK size is increased, run translations, or a number of one-off jobs. We also have a separate set of workflows that need to kick off for each project. For all those projects, there's things like building, linting, unit tests running, as well as uploading artifacts that we have to build. So you can imagine over time, as we had to scale, this got pretty out of hand. We had numerous projects running, numerous amount of builds, all trying to get done as fast as possible. Developers were pretty unhappy as things continued to grow and times increased and stability became even worse. We heard a lot of quotes from people as we reached out to try to understand the problem. Some of these quotes might resonate with you. Maybe you said them before. The build feels slow. The builds take forever now. Are they longer? These all felt really subjective because we really didn't have the data or the observability in place to understand the problem and be able to surface it correctly. So the first thing we did was take a step back and start looking at the tools and data we could use to better understand the problem so that we can then fix the issues. Our first tool that most of our developers were familiar with was DevVelocity. We frequently use build scans as our first source to understand where a problem might exist. And a really easy first win for us was enhancing those build scans. Using the custom user data Gradle plugin, we're quickly able to add additional metadata to all of our build scans that would allow developers to leverage as part of their debugging process. This made it really straightforward for developers to find additional piece of metadata in a place where they were already looking as part of their debug cycle. After that, we needed a better place to see our build pipeline data. Datadog was a tool that we had used on the back end, and so it was our choice here to pipe all of our data into. Our first step here was to sort of establish what we wanted our core KPIs to be that we could track. Things like our P95 and P50, our failure rates and uptimes. We also noticed an issue where our builds were really binary in terms of failure or success. We wanted to add more transparency there and really classify the different error types. And finally, we wanted some insights around the actual hardware itself. So putting in monitoring observability to understand things like efficiency of our CPU usage and memory usage across the different hardware that we were using for builds. As we built these graphs and dashboards up, these became things we would then discuss in our bi-weekly meetings to understand how things were going and the state of our builds that we used to track our success over time so we could really understand what was improving, what wasn't improving, and attach monitoring as well. Finally, as we had a bunch of data in place now to really surface the problems and understand where there were problems, we need a tool for developers that they could use to test fixes. Gradle Profiler for us became a really imperative tool for us to measure these different changes that were usually very high risk and difficult to test. The Gradle Profiler gave us confidence that we could make a change and understand where the deltas were. We invested in a CI workflow for the Gradle Profiler so we could create performance scenarios, run branches against them, and understand where there were issues and where there weren't. But you could also run it very locally just as well. So one example, we wanted to early adopt some new Gradle profiles a bit ago. So we quickly ran against the Gradle Profiler. Here we can see that there was a really big impact in terms of reduction in our times for the builds. So we felt really confident we could roll this out with success. The change was approved, and we all felt good about what was done. Another example where this didn't quite go so well was back when we wanted to understand if we could quickly migrate over to from Dagger Capped over to KSP. We ran through the Gradle profile And we actually saw some out of memories, and we saw some inconsistencies in build times that we didn't expect. This was really early in the days of availability, and given the complexity of our build and infrastructure, we realized that now wasn't the time to make this change, and we rejected this change. So we knew this was something that we'd put in the backlog to investigate further, but this wasn't a change that would help us in the short term with our build times.
Cool. Thanks, Doug. So now I want to talk to you guys about how we used all this data and these tools to actually improve our build times. Specifically looking at our PR build time. So like the jobs that we run pre-merge, because that has like the most effect on developers day to day, except for like their local development. So one of the things we'll talk about is tracking down some unit test performance issues we saw on CI. Identifying like high cost and low value jobs that we are running pre-merge that we maybe didn't have to. And then some AWS infrastructure changes that we made that actually had a great impact to our builds. On the unit test performance side, we saw some pretty high unit test times. And when we dug into Develocity into a build scan, we noticed that a lot of our test tasks had a really high own time. And own time is like time spent in the test task when it is not actively like running a test. And so this seems like something was wrong to us. Some of these values are anywhere between like 50 and 80% of the total time for a task was not actually running a test. So we went and looked at our configuration, our convention plugin, and specifically at our test configuration. And yeah, you may recognize this, you may have this in your build somewhere. This comes straight from like a Gradle page on build performance. And it's basically setting how many tests can be run in parallel based on like the available CPU cores. There are other parts to this as well, but we had an inkling that this might be contributing to the test slowdown that we were seeing. So using Gradle Profiler, we actually tested this value with a bunch of we tested that max parallel forks value with a bunch of different values. And we saw a clear correlation with as the number of max parallel forks increased, so did our overall unit test time. So what we ended up doing was just setting this back to the default value and just left a comment there. So if someone comes along in the future, they don't just, copy what they see on this documentation page and potentially cause a regression in build times. Once we made that change, looking in Datadog, we were able to easily see a huge drop in our P95 for one of our unit test tasks. So this is the largest project in our code base. We saw about a 30% drop because of that. P50 remained like relatively unaffected. Now I want to talk about eliminating high cost, low value jobs. And what I mean by that are like jobs that we were running on pre-merge that we didn't think had brought a lot of value. So our Android code base is about 12 years old at this point, and we had been accumulating a lot of jobs over the years that people would add in. So the first thing we did is just like take inventory of all the jobs that we were running, all the tasks that we were running, and understand, are they actually valuable? And if not, can we remove them? Or if we can't remove them, can we just do them post-merge? One of the things that we quickly saw was that running obfuscated release builds on PRs was very time consuming. At the time we were using DexCard, and it was taking anywhere between like 30 to 50% of our total build time. You can see here from this build scan, it took 38 minutes for the entire task, and 17 of that minutes was just running DexCard on that APK. Talking with the feature teams, like running this on PRs wasn't that useful for us. So we decided that, hey, this is okay. We could not run this on pre-merge and just do it post-merge. And there's a little bit of like increased risk there, but it was an acceptable risk for us. And after doing that, we saw a drop both in our P95 and P50 for build times for that project. Now I want to talk about identifying slow tests. And these aren't slow tests because of misconfiguration like we had before. These are tests that are just like actually slow to run. And so going back to Develocity and looking at a build scan, when we sorted our test tasks by by how long they took, one thing became very clear is that all the tasks that took a very long time all had Robolectric tests. For non-Android engineers, Robolectric tests are a way, like a test framework that allows you to test code that interacts with the Android OS. But at this point in time, we didn't consider them to be that valuable. These were added to our code base a long time ago before most things, really had a testable architecture. And now they're mostly redundant because we had unit tests or integration tests there. We also kind of hypothesized that this small number of tests was taking the majority of the time for our test tasks. So after talking with the feature teams, again, they agreed like this isn't something that they wanted to do. They haven't written a net new Robolectric test in years. And so they agreed that like we should work to remove them from our code base. So over the course of several months, the teams worked to remove Robolectric, and we saw a pretty constant decrease in both our P95 and P50 as a result of that. Now, this isn't to say if you delete your tests, like your builds will be faster, but like understand like what you're running and if it's actually valuable for you and all your engineers. After this, I want to talk about some AWS infrastructure changes that we made as a result of kind of like a happy accident. So our orchestration team rolled out a change in our build cluster to increase efficiency, increase like resource utilization. And luckily we had Datadog in place because we saw a huge spike in our PR times because of that. We were seeing, timeouts on CI, like things were not good. What ended up happening is with this increased efficiency, we're scheduling more of our runners on a single underlying EC2 instance. And this seemed to be causing an IO bottleneck. This was before the DevVelocity feature where you could see the IO stuff. So it was a little bit harder to track down, but we saw like a 500x increase in the fingerprinting inputs part of a task. That just indicated us like something was wrong with IO and like we needed to figure out what was going on. So this particular task was pulled from cache. It only took 200 milliseconds, but it spent over 6 minutes to actually figure out all the inputs to that and create the cache key. After working with our DevOps team, what we found was that all of our builds were being scheduled on these AWS instances with EBS-only storage. Now, I'm an Android engineer, so I don't have a ton of experience with AWS or like cloud infrastructure, but we just made a simple change to move to instances with NVMe disks, and we saw a huge improvement in our build time. So if you're running on like these, like what I'll call default AWS instances, maybe try ones with NVMe disks and you'll see an improvement. So not only did we like fix the volatility that we saw as a cause of this, the rollout of the change in our build cluster, but we actually saw a significant drop below our like actual baselines before that change. You can see here for the build task for that large project, our P50 dropped like almost 50%.
Awesome. So with all those changes, where did we land? Now, given the duration of this talk, we couldn't get into everything we did. There are still a number of optimizations we continue to make once we had the build stable in a good place. So from the test side, we wanted to continue optimizing the speed our unit tests are running. So we've been utilizing DevVelocity's predictive test selection and test distribution. We also do some caching on our dependencies that we would prefetch. And we did some work to remove DexCard in favor of R8. All these added incrementally to our overall new build times, which we're super excited to share, reducing P95 from 64 to 30 minutes and our P50 from 44 to 16 minutes. So overall, this was a huge win for the team. Our developers have become significantly more happy. Nothing feels on fire anymore. And anytime things go wrong, we have the tools not only to understand how to fix the problem, but we have the monitoring observability in place to understand that there's an issue that we can surface to the appropriate people to resolve. And that's it. Thank you very much.
Thank you.